A very good day to Dr. Mariam. We are from Group 3, Section 2. So today we are going to present for our AM transmitter. So our member consists of 5 members, which are Liu Guanyi, Noor Aina Maisara, Ainul Maratiha, Mohammad Akmal, and Chu Yong Kong.
In this project, we are required to develop a AM transmitter for community radio station with coverage area of 1 kilometer. The transmitter should adhere to regulate the requirement and provide high quality audio transmission. This comprises the creation of transmitter hardware, modulation, and the control system, as well as the installation of suitable antenna and the transmission component. So we will focus on the AM transmitter and the broadcast of the audio signal with a carrier signal by changing the amplitude of the input signal, and the AM receiver is used to demodulate the AM signal to its original signal with a specific bandwidth. So the next is filler table, and the first fact is antenna system are crucial for the signal propagation, and our idea is connect the antenna and ground and tune to get a strong signal in the radio. And the learning issue is how to design a basic antenna system for AM broadcasting, and the action needed is construct and test the antenna system for optimal signal propagation. For the second fact is AM signal can travel long distance but are susceptible to interference and fading. The idea is to investigate the signal propagation and characteristic, and what the learning issue is, what are the common sources of interference in AM transmission. Action needed is to develop a strategy to mitigate the interference. So the third fact is to the coverage area of the AM transmitter depends on the factors like power, frequency, and the antenna design. So we need to discover the strategy to increase the AM transmitter coverage area, which could include updating the antenna system. So the learning issue is what are the key challenge in extending the coverage area of an AM transmitter while complying with regulatory requirements. So the action needed is we need to do the test to learn how the alternative antenna layout and the power levels affect the coverage area. So the fourth is the AM transmitter used for broadcasting audio signal while the amplitude modulation. So we need to exploring the antenna design for the better signal propagation. And the learning issue is how are the audio signal modulate onto the carrier wave, and we need to doing the experiment with the different antenna and modulation source to improve our module. And the fifth is typically operate in the medium frequency band, and we think about the frequency range that is appropriate for the band for using in our module. So what are the advantages and limitations on the medium frequency band for AM transmission, and we need to discover the NF band frequency characteristic and show how they relate to the AM transmission.
So now I will explain about the circuit design, block diagram, and also the description of the system. For your information, we are using multisim to come out the design of the circuit. So to understand this circuit, how this circuit will generate the uh, sounds, as you know that circuit will generate radio frequency signal using a single transistor Q1 and a tuned circuit which is between the L1 and C4. The sound wave from the microphone will trigger the Q1 biased by the voltage divider rule, which is R1 and R2. The tune circuit will connect it to the Q1 collector, and it will enable it to operate at a specific frequency. So the activation of this circuit will transmit the frequency to the oscilloscope, and oscillating process happen to determine the frequency. The radio frequency signal will send to the antenna link to the oscillator output, matching the same frequency between the transmitter and receiver will lead in producing sound in the radio. So this is the block diagram on how this process of the signal will transmit the signal to the antenna. So here we are using the Class C amplifier. Class C amplifier are commonly used in the radio frequency power amplification stage of AM transmitter, particularly in amplification where power efficiency is crucial. When the sound wave produced by the music strike the diaphragm of a microphone, it will convert to a tiny varying current. The audio frequency output of the microphone is amplified by a low-level audio amplifier and finally transmit to the power amplifier. On the other side, the carrier wave of radio frequency are generated by a control oscillator. These carrier waves are applied to a turn buffer amplifier and transmitted to a radio frequency output amplifier. The buffer amplifier is used to isolate the radio frequency oscillator and the power amplifier stage. The amplifier audio signal is then combined with the carrier to give a modulated carrier wave, which is fed to the transmitter antenna. For the description of the system, it consists of six parts, which is carrier wave generation, audio modulation process, radio frequency amplification stage, antenna transmission, and also consistent power supply. So for first thing is which is the carrier wave generation. The process is the transmitter initiate with an oscillator circuit using either an LC circuit or a crystal oscillator to create a stable carrier wave in the medium wave band within a specified AM frequency range. After that, the audio modulation process will happen. An audio signal, often from a microphone, is introduced to the carrier wave through an audio modulator. It will cause variation in the carrier wave amplitude corresponding to the audio waveform. After that, it will continue with the radio frequency amplification stage. So, following modulation, one or more radio frequency amplification stage will boost the signal power to enhance transmission efficiency. After that, an antenna, a critical component that transmits the modulated signal into space, receiving the boosted signal. The length of the antenna is generally adjusted to be approximately a quarter wavelength of the desired frequency for the greatest result. A consistent power supply is provided to run the whole system and maintain consistent of the performance. So for input and output analysis part, so first input analysis, when a modulating information signal, typically a sine wave, is introduced, the amplitude of the carrier wave fluctuates in sync with the changes in the information signal. So besides shown our waveform that we get, so first voltage peak to peak 72 millivolt, so frequency 123.08 Hz. So it tests from positive audio jack. So audio stage amplifies increase the weak signal coming from the microphone. So the frequency from circuit to radio transmit from antenna is 140 kilohertz. So next is the video shown that we get the input signal.
118. Yang tadi sini berapa ni? 1, 2, 1, 3.
So for subsystem output analysis, the message is transported by the carrier wave, which has a constant frequency. It serves as a medium for superimposing the amplitude changes caused by the modulating audio stream. This modulation process is essential for the encoding and transmission of information. So beside shown that our waveform that we get. So first for voltage peak to peak is 39 millivolt. For the frequency we get 1.52846 millihertz. It tests from inductor. So the audio signal is modulated onto the radio frequency carrier in this modulator stage. So here shown the video. We get the subsystem output waveform.
For the output analysis, a frequency of 1.572 MHz and a peak-to-peak voltage of 46.4 millivolt is revealed in the output signal analysis. This wave exhibits a smooth escalation without any noticeable phase shift, with an amplitude of 23.2 millivolt and a peak voltage of the same magnitude. This wave period or the duration of a full cycle is determined to be 1 over 1.572 MHz. The symmetrical and smooth waveform of the signal highlights its harmonic regularity and serves as an example of a high frequency oscillation. This through examination offers a clear representation of the frequency, amplitude, and general waveform characteristics of the output signal, giving it a thorough understanding of its basic properties. The end product is a concise but in-depth analysis of this dynamic and well-defined signal. Okay, for part of discussion in the realm of communication systems, particularly within amplitude modulation (AM), the carrier wave plays a pivotal role as a consistent conduit for integrating amplitude variations induced by the modulating audio stream. This essential modulation process, a cornerstone for encoding and transmitting diverse audio content, such as music, speech, unfolds as the carrier wave transforms into a dynamic canvas. It embraces the characteristics of the audio signal, facilitating its propagation over the airwaves. The modulation journey involves adjusting the carrier wave's intensity in direct correlation with the immediate amplitude of the signal, ensuring that despite punctuation, the carrier wave maintains a step-5 frequency for the receiver to efficiently information without distortion. So for figure 3.2, visually illustrate the waveform of the carrier signal from the modulator circuit, revealing a frequency of 1.523 MHz and providing a tangible insight into the carrier wave characteristic. Essentially, the carrier wave stands as an empowering, reliable channel dedicated to faithfully transmitting audio signals. Detailed output signal analysis further enhance our understanding, showcasing a harmonious sine wave with a frequency of 1.572 MHz, a peak-to-peak voltage of 46.4 millivolt, and a smooth oscillation without noticeable phase shift. The second, yes, yet comprehensive analysis delve into the fundamental properties of the signal, emphasizing its high frequency nature and symmetrical features, contributing to a clear representation of the dynamic behavior.
In conclusion, AM transmitter have various real-life applications, despite having the older technology if compared to FM transmitter. But our group still managed to design an NM transmitter that has the frequency of 1.572 MHz, which is within the range of AM transmitting frequency. And our AM transmitter also is well suited for specific applications where moderate to long-range transmission is required. Besides, the amplitude modulations at 1.5 MHz allows for reliable communications and is known for its ability to cover extended distance, especially during nighttime when atmospheric conditions enhance our signal's propagations. That's all from our group. Thank you.